So we ended with coterminal. And the last thing that I want to talk about in this is conversions. So I think, I don't know if it's in physical science or chemistry, you've done some conversions in your science classes before. There are different ways of doing this. We have a wheel makes 270 revolutions per minute. Through how many degrees will a point on the edge of the wheel move in 5 seconds? Now there are people that they can just look at this and their mind works and they know exactly what they need to do to get the answer. And if that's you, as long as you're showing me what you're doing, that's fine. I prefer to write things out to make it a little more clear. So I'm going to set this up using conversions. So right now, I know makes 270 revolutions per minute. Per is like a divided. So we have 270 revolutions per, so divided by minute, so that's 1 minute. Okay. My goal, I want degrees. So the first thing I have to do is change my 270 revolutions into degrees. So let's think about that. What does a revolution mean? All the way around the circle, right? How many degrees is all the way around the circle? So 1 revolution is 360 degrees. I want to get rid of revolutions. If it's on the top of the fraction, where do I have to put it to cancel? The bottom. So I'm going to put my 1 revolution down here, and that's equal to 360 degrees. So I'm going to put my degrees on top. So right now what happens is those revolutions would cancel out. My units now are degrees per minute. Okay? Looking in the problem, I just want degrees. I know we have 5 seconds. So what do I need to change my minutes to? Seconds. Okay. 1 minute is the same thing as? Do I want to put the minutes on the top or the bottom?
Top.
Top, because I need it to cancel. So 1 minute is the same thing as 60 seconds. So those cancel. What other information is given in the problem? We're spinning for 5 seconds. So if I just multiply by that 5 seconds, because that's how long it's moving, those seconds cancel. The only unit I'm left with is degrees. And isn't that what I wanted? How many degrees? Okay. So then we just multiply and divide. So you're going to take, multiply everything on the top, 270 times 360, hey, come on in, times 5. And what do I have to divide that by? 60, because that's on the bottom. So that gives me 8,100, and my unit is degrees. So this, some of you may not have to write out all of this, but eventually we're going to get to more problems that require some conversions, so I just like to get in the habit now, since that's what we'll do later on. Okay, why don't you guys try B? So we know it makes 480 revolutions per minute. I need to know how many degrees it will move in 2 seconds. So change your revolutions into degrees. So we want the revolutions to cancel. It has to go on the bottom. 360 degrees is equal to 1 revolution. I'm talking about seconds. So I'm going to put 1 minute on top over 60 seconds. And and I know that it moves for 2 seconds. So multiply by 2 and those seconds cancel. So then all you're left with is the degrees. So if we multiply 480 times 60 times 360, excuse me, times 2 and then divide that by 60, 5,760 degrees. We all get that, I think? Alright, so that's the end of section 1. We'll go ahead and teach section 2, and then tomorrow we have the workday. I gave you guys the section 1 homework already, right?
Yep.
So you have that written down. Okay, so section 2. This is a lot of geometry in one section today. So we're talking about angle relationships and similar triangles now. Yeah, sorry, I didn't have it today. I was less nice today. It's the second day back. Who cares anymore? Okay, first thing, if you've had geometry, you remember talking about all those angle relationships when you had the two parallel lines cut by a transversal. Do you guys remember those? We're going to go over those to begin with. So if we have two parallel lines, I'm just going to put that symbol means they're parallel, and they are cut by a transversal. So there's just some line that goes through both of them. I'm going to number off my angles. Make sure on your notes you write the same numbers I do. Otherwise nothing's going to make sense. Okay. So we can classify, there's a lot of different terms that we can use to describe these angle relationships. I am not going to give you a test and say identify the alternate interior angles. But I might give you a problem, like a picture, and ask you to find a measurement, and so you need to know which things are equal and which are not. So I'm going to give you the terms, but I will not be actually like quizzing you on the names of those things. So alternate interior angles. The name kind of tells you what they are. Alternate means opposite sides. Interior means inside. So they lie inside the parallel lines, but opposite sides of the transversal. So if I take angle 3, it's on the inside. What would I pair it with? 6, because they're on opposite sides. So a set of alternate interior angles would be angle 3 and angle 6. There is one more pair of alternate interior angles. What would they be? 4 and 5. Okay. So the thing that I really need you to know, what's true about the measurements of those? Anybody remember? I'll give you 2 guesses. It's either they're congruent, same measurement, or they're supplementary.
Congruent.
They are congruent. Alternate interior angles have the same measure. So these are congruent. talk about alternate exterior angles. Alternate means opposite sides. Exterior would mean what? Outside the parallel lines. So give me a set of them.
7 and 8.
And the other set?
3 and 7.
Okay. If we already know that 3 and 6 have the same measurement, what would you know about 1 and 8? They're congruent as well. Okay. Next relationship I want to talk about. Your book calls this same side interior. Sometimes it's called consecutive interior. I don't remember which one the geometry book used. Do you guys? Did it do consecutive? Okay. They can be referred to either way. It's the same thing. So interior means inside the parallel lines. Same side or consecutive means they're on the same side of the transversal. So what would that be? Give me a set.
4 and 8.
4 and interior is inside the parallel line, so it would have to be
4 and
6.
6. Okay.
And the other set would be?
3 and 5.
Okay. So let's see if we can figure out the relationship between those. We already said 4 and 5 have the same measurement, right? What would be true then about 4 and 6?
Make 180 degrees.
Yeah, they would add up to 180 because these two together make a straight line. So these are supplementary. Okay. Next set, I want corresponding. Angles. Corresponding means they are in the same position. So for instance, angle 1. It is to the left of the transversal and above the parallel line. So it would correspond to another angle that is above the parallel line and to the left of the transversal. So that would be?
7.
7 is below the parallel line.
Okay. 1 and 5.
Okay, so then 2 would match up to
6.
3 and someone else.
7.
7. And the last one, 4 and 8. Alright, what is true about those measurements? What do you think? It was a 50-50 shot. They're either congruent or supplementary. Congruent. The last one. Vertical angles. Vertical angles make an X. They're across from each other. So if I'm looking at this, angle 1 would go with What's across from it? 4. Angle 2 and angle 3. Angle 5 and angle, and 6 and 7. What's true about those measurements? Can go ahead. So the same side or the consecutive interior, those are supplementary, but the rest of them are congruent. Again, I'm not really going to test you on those relationships so much. The ones that we use the most would be the alternate interior, sometimes when we start looking at some of our diagrams, but it is important information to go over. Alright, we ready for an example? I'll give you a second if you want to draw that picture in your notes. Okay, so I want the measures of angles 1, 2, 3, and 4. We have some information about 2 and 3 in our picture. What do you know about angles 2 and 3? Do they have the same measure? Are they supplementary? What are they? Supplementary. They're on the same side of the transversal. So what I can do is add them together. And since they're supplementary, they have to equal 180. Adding like terms, so 16x plus 4 if we divide by 16, we get 11. My directions were to find the measures of each of these angles. So 2 and 3 are easy. I just have to plug my x back in. So for 2, 9 times 11 is 99, plus 9 would be 108. Remember to put the degree symbol. If I plug it into 3, I get 77 minus 5, which is 72 degrees. Okay, angle 1. What do you know about it? It's a vertical angle with 2, so they have the same measurement. So it would also be 108 degrees. How could I get angle 4? Somebody tell me something. Corresponding with 2, so they have the same measurement, so it's 108. You could have also recognized that 3 and 4 together make a straight line, so they're supplementary, and get it that way. So lots of ways we can get there. Okay, any issues with that one? Okay, if I am talking about a a triangle, what do the angles in a triangle add up to?
180.
180. Okay. So you might need to jot that down if you've forgotten that. The sum of the measures of the angles in a triangle is always going to be 180 degrees. Alright. So here is an example. I want you guys to do it on your own. So 180 minus 33 minus 26, and what did you guys get?
121.
Alright, is that okay? What if I said the angles of your triangle were 12 degrees, 51 minutes, and 100 degrees, 13 minutes? What would you have to do to find the third angle there?
Find a precise angle.
Okay, so what should I do with these two to start? You want to add those together and then subtract from our 180? So now that we have degrees and minutes, you can expect that I'll probably put some of these on there as well. So if I add my minutes together, we get 64. And that's 112 degrees, 64 minutes, except how should I rewrite this?
213 degrees and 4.
Okay, and then we have to do what? Subtract from 180. So remember, this is 180 degrees and 0 minutes, so we have to borrow just like we were doing yesterday. When I bring over my degree, how many minutes is that? 60. So 60 minus 4 is 56. 179 minus 113. So we get 66 degrees, 56 minutes. And I could throw seconds in there too if I wanted. It takes a little bit longer, but it's the same. Alright. Let's talk about classifying triangles. We can classify triangles based off angles or sides. So if I'm classifying based off my angles, if I said acute, an acute triangle, what does that mean? And in a triangle, that means all angles have to be less than 90. If it is a right triangle, what has to be true?
One angle, 90 degrees.
If it is an obtuse triangle, what does that mean?
One angle, 90 degrees.
Can you have two angles bigger than 90 degrees?
No.
If you add them together, it would add up to more than 180. and we couldn't have the third one be negative, so only one. Okay, if I classify based on the sides, we have equilateral. What does that mean? Isosceles, which means two equal sides. And scaling, talking about triangles, what are similar triangles?
They look all the same.
They look the same. What's the same in them? Remember, if they're completely the same, then they would just be congruent. So similar, that's when all of the angles are congruent. So triangles with equal angles and proportional sides. In other words, if I had this triangle, a similar triangle would be if I just doubled each of the sides. I kept all the angles the same measure, but I took each side length times 2. That would be a similar triangle. So I've got like 2 or 3 examples, and then we are done with this section. Any questions on the triangle pieces? Okay, so looking at this picture, the 2 triangles, DEF and GHI, are similar. Just a tidbit to help you in the future. When you say triangles are similar, I labeled in the picture which angles were the same, but you could also get it from here. So angle D was listed first, so it's going to be the same as G. E and H would be the same, F and I would be the same, so the order matters. Find the measure of angle G and the measure of angle I. So G is the same measure as which one? D, and I know D is 53 degrees, so the measure of angle G is 53 degrees. Measure of angle I would have to be the same as F, so 29 degrees. So just remember, on those similar triangles, angles are equal. Let's do one with the sides. I'm going to put this up here. I'm going to give you a minute to draw the picture in your notes before we solve it. So jot that picture down for me. So I'm telling you the triangles are similar. that means their angles are equal. I want you to find the sides. So let's call these some variables here. I want to find the unknown sides of QSR. So we usually use capital R for the angle. The side opposite it we would just call lowercase r. So this would be lowercase q. Those are the two things I need to find. To do that, we can set up a proportion. So we're going to take two sides of this. If I want to find r, I'm going to say r over the only other side I know is 12. Equals, and then we're going to do a proportion using the corresponding sides in the second triangle. So r matches up with the side of 10. Okay, 12 corresponds with the side 8. So r over 12 equals 10 over 8. Does everybody see how I set that up? Then we can just cross multiply this off. So you get 8r equals 120. Divide by 8. And r is 15. Give me a proportion to find q. Connor, tell me the first half of it.
Would it be q over 12?
That would work. Alright, so Gus, if we pick those, what would you do for the other one?
Equals 15 over 10.
He did q over 12. So he picked these two sides. So pick those sides in the other one, so it would be 12 over 8. Yep. Alright, so then if we cross multiply, we get 8q equals 144. And q is 18. There are multiple ways you can set these up. You just have to get a valid proportion. So just pick a side from one triangle has to match up with the corresponding side in the other. Alright, we're going to do one last problem like this and then we're done. Okay. I should not give you the picture. We should draw our own. Okay, Samir wants to know the height of a tree in a park near his home. The tree casts a 38-foot shadow. So if I'm drawing a picture here, I've got my tree, and I am quite the artist, so you know this is going to be beautiful. Where does the shadow go? On the ground, yes. I asked that because I cannot tell you how many times I've put a question like this on a test or a quiz, and people make the hypotenuse the shadow. Like, lots of people. So shadows go on the ground, okay? We're trying to find the height of this tree. I'm looking at shadow, it's on the ground, and that shadow is 38 feet. Okay, then I have Samir here. I know he is 63 inches tall, and his shadow is 42. Now, there is a slight difference because my units are different. You'll notice I'm measuring his in inches and the tree in feet. That's okay as long as in the triangle all the units are the same. So as long as in this triangle everything is feet and this one everything's inches, it's not a big deal. So we have two triangles. I'm trying to find the height of this one, so I'm looking for x. So if we set up our proportion, what would it be? Sierra?
X over 38,
Huh?
and then 63 over 42.
Yeah. So we get 42x equals 63 times 38 2394. Divide by 42. And we get 57. Notice the height of the tree, so that's in feet. Any questions there? So we have covered the first two sections. Here is the homework from section 2. This will be due Friday, work day tomorrow. So I am not teaching anything tomorrow. You get the entire class period to work on your homework. But I actually was going to remove 41 and 44, if that's okay with you.
Wow, can't believe you did that.
I know. If it really upsets you, you're welcome to do them, but you don't have